Bismillahirrahmanirrahim. This short video is about properties of linear time invariant system. It is article 2.3 from the book. And in this video, we'll be discussing the commutative property and distributive property. The commutative property is very simple. And if we talk of discrete time, then you can see that xn convolution of hn or convolution with hn can also be written as xn hn first and convolution of xn. So their places have been changed basically. And similarly in the continuous time also, xt convolution ht is equal to ht convolution xt. And to prove or to verify, we'll proceed as follows. We know that in the discrete time case, we can define the convolution of the two terms xn and hn as summation of xk multiplied by hn minus k, and the limit from minus infinity to plus infinity. Now, if we introduce a variable r such that r is equal to n minus k. So this n minus k we are replacing with r, and once we have assumed this, then from here we can also find that k is n minus r. So k we bring on the left hand side and r bring on the right hand side. So k will be equal to n minus r. So this k can be replaced with n minus r. And so from this equation, we can now write that this thing is equal to, remember k has been replaced with n minus r, so x k will become x n minus r. And similarly, h n minus k will become h r, because n minus k is equal to r. And now the limits will be, now k minus infinity or k equals minus infinity, will now write it as n minus r equals minus infinity, and similarly the other end will be plus infinity. And now if we see this one, that when n minus r is minus infinity, we are talking of this thing, then if you bring the infinity on the left hand side and take r on the right hand side, then n plus infinity is equal to r, or you can say r is equal to n plus infinity. We bring r here and this one on the right hand side. Now anything added with infinity will become infinity, therefore r will become, the limit of r will become positive infinity. So this was for the bottom part. So we can replace this thing with r is equal to positive infinity. Now the other end of n minus r equal to plus infinity, same way we bring it here. So it is n minus infinity, r goes on the right hand side, and we can write r is equal to n minus infinity. And so anything added with minus infinity will remain minus infinity. So the other limit of r is minus infinity. Therefore, the limit of the infinity now we can replace easily, and the limit will now become minus infinity to plus infinity. Actually, according to this, it would be plus infinity at the bottom and minus infinity at the top, but we can also write minus infinity at the bottom and plus infinity at the top, no change. And we are just rearranging this. We are writing hr first and xnr. And now if you look carefully, this is the formula for convolution of xn into hn into xn. So you just now look at this, xn into hn, this we converted all the way to this form, and this can now be written as xn convolution hn. So we can now say that the left hand side is equal to right hand side. So this one is equal to this right hand side. Okay, now we come to the second property, which is called the distributive property. And I'm sure you have learned the distributive property in the college as well. So what it is saying that x convolution with h1n plus h2n can be written as the convolution of xn and h1n plus convolution of xn and h2n. So this convolved with this, and also this convolved with the second term, and similarly for continuous time. And if we want to represent this graphically, so what it is saying that the x convolution with h1t plus h2t, so x convolution with h1t plus h2t is same as x convolution with h1t, x convolution with h1t going to the summer, so plus x convolution h2t going to the summer, and this is the final answer. So this can be this can give you a graphical idea what we are talking about. Okay, as a consequence of both commutative and distributive property, we can have another property that if we have the two variables x1 and x2 and they are convolved with hn, so this can also be written as x1 convolution hn plus x2 convolution hn, and similarly for the time domain. And this we can also represent graphically: two inputs x1 and x2, x1 and x2 added, summed, convolved with h1, convolved with hn is same as x convolved with hn plus x convolved with hn, x1 convolved with hn. So this is this should be h2 convolved with hn. So this will give you y2, and the final result will be the sum of the two. So x1 convolved with hn here plus x2 convolved with, this should be x2 convolved with hn will give you the final answer. So this is the graphical representation. Now, as illustrated in the next example, the distributive property can be exploited to break a complicated convolution into several simpler ones. And how to do that? Let's see with this example 2.10. Now, this is the input. You can see it has two parts, and this is the impulse response. Hn is actually equal to un. And we have to find the convolution of these two. Now, the direct evaluation of such convolution is somewhat tedious. If you want to solve it directly, it will become very difficult. So what we'll do is we'll take help of the distributive property, which is this property. And as you know, this could be broken down into two parts. So x1 convolved with hn and x2 convolved with hn. Now in our case, xn is given like this. So the first part we call x1 n, and the second part we call x2n. So using this formula, we can find the answer separately for these two parts and then add to get the final answer. Okay, so this means the first part, this one, convolved with un, because hn is un in the question here, you can see. Similarly, the second part, this part, convolved with hn, that is un. And when we solve this, we will call it as y1n, and when we solve the right hand side, we call it as y2n, and the sum of the two will be the final answer. Okay, so we were here, and now we had done example 2.3, if you recall, this was xn and hn was un, and the result we got was yn 1 minus an plus 1 divided by 1 minus 1 un. And this, when we plot it at n is equal to 0, so putting n is equal to 0 here, the value at this point will be 1 divided by 1 minus a. So this we had solved in example 2.3. Now we compare our first part, this part with this one. So here it is a power n un, here it is half power n un, so that means a is actually equal to half. So if you put a is equal to half here, and whatever the answer we get will be the answer of the first part, or the plot of the first part. So let's see that. So this is the plot of the first part when we put a is equal to half. So this is 1 minus half will be half, and 1 over half will be 2. So this value is 2. The other everything remains same shape, just the value we are changing. So this is the answer for the first part. Similarly, we had done another problem, 2.5, where we had used exactly same question. So 2n u minus n, 2n u minus n, and hn was un. And in that case, we got this answer. So we'll just copy this answer and we'll call this y2n. So this is our y2n. This is our y2n. And now for the final answer, we'll add these two. So adding these two, we get this final answer, that is yn is y1 plus n plus y2 plus n. So if you add, let's say this point is 2 here at 0, and here at 0 this is 2, so 2 plus 2 will be 4. So at 0 the sum of the two will be at 4, or the maximum point will be at 0, this is the value, so this value is 1 actually. So 1 plus this 2 will give at 0 this value 3. The maximum value that we are getting here is 2, and the maximum value in this case we are getting is also 2, so 2 plus 2 is 4, so that is the maximum value. Similarly, if you add, now look, this is 0 here, but on the left hand side here it is 1, so this will remain 1. At minus 2 it is half, so half plus 0 will also remain half, and minus 3 it is 1 over 4, so minus 3, 1 over 4 plus 0 will also remain 1 over 4. So this is the final answer. So you can see that by using this property, we have simplified a tedious answer, a tedious problem, to get a simplified answer. Thank you.